When I got back into this hobby of model railroading, one of the many channels I started following was Jimmy's DYI and Digital channel. I still love his straightforward topics and passion for the hobby, but I think one of my favorite things is how he explains using Ardunio and adding automation to your layout. I knew right away one of the first bits of automation I wanted was remote switching controls. Now, I do know that Kato has their own switch controllers, but they make it hard to identify which switch is where and what tracks will be selected. What I wanted was a board with a line representation of the layout, and when I pushed a button, the switch would cycle and a light would show me which route was now clear. After picking up an Arduino kit, I set about getting a simple code up and running to switch some Kato switches. I know I had a video of the breadboard setup with the left and right switches hooked up to just one button and alternating LEDs, a green and a blue, but I couldn't find it. However, I did find these two pictures. With green lit, both are going straight, and with the blue lit, both are diverging. I do want to show you what I modified from Jimmy's code. So the only native coding on my part is what I'm going to show you. Again, the original code is for 3 switches and no LEDs. And you can go find out on Jimmy's channel, which I'll link below. All right, let's see if I can do justice to what Jimmy did and what I added. So you can see here, the first thing I did was come into our integer selection and I added a whole bunch of LED underscore turn 1 and LED underscore STR or straight 1. I also did it for 2, 3, and 4. And I assigned them various pin numbers. Now you'll also notice if you are working from Jimmy's code, I have reassigned a lot of pin numbers, and I have a graphic that I'll put up afterwards to explain why I did that. Basically, it was ease of layout of putting things closer together for when I go to hook this up on the layout. In the second set of switches is where Jimmy added the switch 3, pin 1 and 2. I came back in and added those constant integers of switch pin 4, or switch 4, pin 1 and pin 2, and we also came back in and added button 4. Again, into the integers list, we had to set up state 4, which holds the value of where switch 4 is. In our pin modes, the change again is adding the switch 4 pins 1 and 2 and setting them as outputs. And then all of these pin modes here are new, and they set up all the LEDs as outputs as well. That way we can send power to the LED to turn them on or turn them off. In the enumeration of our switch states, again, pretty simple. We had to add ST underscore straight 4 and ST underscore straight 4. And that sets up the states that the Arduino can hop around when it's in its main void loop. And so when we come into the switch states, we start off by defining off, and we have to add our button 4 read as an analog read, button number 4, obviously. And we need to also come into our cases and add button 4 read to every single case that we have, plus the 2 new ones we need to add, these cases being ST underscore straight 4 and a case for ST underscore turn 4. And again, we're telling it what buttons to read. And now we come into the cases, or the little mini programs within the program. First one's switch off, which we have to add an integer to that of button 4 read, so it knows that it can go get it. And we're going to digitally write switch 4 pin 1 low as well as switch 4 pin 2 low. And that's the case for all the switch pins. We want them all to be low, so when we start the Arduino up, all of our switches will be turned off and not frying them up. Into our if-then statements, you can see we again have to come back in and add st straight 4 and st underscore turn 4. And it's simple as just cut and paste and adding those in. But remember, you need to set state 4 equal to the double equal sign. So it needs to be 1 if you're going straight, and it needs to be 0 if you're going on the turn. And so in each of the cases, each switch state, we need to add button 4 read, so it knows it's there. We also need to add digital writes for switch 4 pin 1 and pin 2. And until we get to switch straight 4 and switch turn 4, these will all be set to low. So you can pretty much write it once, cut, and paste. In addition, this is where the LEDs come in. I added this. You saw the panel. I need to know which switch is which direction. That's the whole point of this. So I added these digital writes. LED underscore turn 1 is low because we're in straight. And LED underscore STR1 we set to high, so we turn that LED on because we're in straight. And you can see here when we go to switch turn 1, now it's the opposite, right? Now we have LED turn 1 is high and LED straight 1 is low. And let's do the same thing with 2 and 3, and then again a big cut and paste from 3 for 4. The difference being here, all these are going to be low except for switch 4 pin 1, which is our turnout going straight. So we'll power that on, and we'll again turn the straight LED to high. And we need to, instead of state 3, we need to go to state 4 as 0. So that'll go back and be ready to go the opposite direction. And the same thing in the turn. Add our button 4 read and turn switch 4 pin 2 to high and turn switch 4 pin 1 back to low. So there, that's in low, that's in high, and turn on our turn LED and turn off our straight LED. And I went through that very quickly. I will put a copy of this out there somewhere, but that's all I did to modify it. So here's a picture of the Ardunio Nano that I used. The pin layout is the same as the Uno. Circled in black are the switch pins. 2 sets of 4 leads go from the Nano, one to one of the motor controllers and one to the other motor controllers. Circled in red are the button pins. The positive leg of the buttons go to these pins, along with a 1K resistor, each connected to a common ground. And that pin is only 2 locations away from the ground, which is labeled as G and D. All the LEDs are circled in blue, and each switch has a pair of lights that are grouped next to each other, except one, which are set up on opposite sides of the Nano because I ran out of pins on one side. This arrangement made the connections really easy to install and to troubleshoot. Now, I'm not going to show you the rat's nest of wiring on the back side, but there are tons of extra wire and soldering joins of common wires, and it's just a mess. Besides, Jimmy has a much cleaner and clean installation video that I'll reference in the description. Okay, here are all the buttons, save the hidden ones, in action. So until next time, happy railroading.